We are recording. This is the fifth and last lesson in grade 12 probability unit in Essential Math. And it's pretty much the same idea as the last section, only with more real-world type examples. Example number 1. A city is interested in knowing how many of its roads and sidewalks need to be repaired. A city engineer randomly inspects 38 city roads and finds 4 that need to be repaired. He also finds that 6 of the 45 city sidewalks he inspects needs to be repaired. So, based on this historical evidence, what is the probability that a city road has to be repaired? So, the roads part of the question was 4 out of 38. 4 out of 38. Okay, if you leave the answer like that, you're going to lose half a mark. What do you notice goes into 4 and 38? They both have a 2. So that's actually 2 out of 19, which, if you'd rather have a decimal, is 0.105. And there's a repeat on that, but I'll just round it to 3 places. 19ths take like 12 or 13 digits before they start repeating, so yeah. What is the probability that a city sidewalk has to be repaired? So the sidewalks are 6 out of 45. So that would be, what goes into those 2 numbers for sure? 3. They both have a 3, correct. So that's 2 out of 15. That one I happen to know. That is actually 0.13 repeating. I didn't even need to punch that one. And, okay, based on this information, which one do you think the city should tackle first? Well, if I'm going to base it on the probability, otherwise why'd I hire the guy to walk around and count in the first place? I would say, based on probability, the sidewalks are more likely to need repair. Do you get why I'm saying that? This is a higher probability than that, right? This is a 13% chance. This is a 10.5% chance, if you want to think percentages. Now, there's, of course, the moral argument of, well, yeah, maybe the roads are more important. Well, maybe not. Maybe wouldn't the sidewalks be more important? You hit a bad spot with a car, you're not going to get hurt, right? Whereas a sinkhole in a sidewalk is going to kill somebody. So I don't know, or maybe the opposite's true. I mean, big deal, you trip on a sidewalk, whereas a really bad sinkhole on the road could cause a vehicle to careen into several pedestrians. Then what? So maybe there's deeper issues here than the probability. But if you're just basing your decision on the numbers, the numbers say these are worse. So let's fix those first. There we go. Okay, so that's the first example. Example 2. Aaron is thinking about adding collision insurance when he renews his car insurance policy next year. This will increase the cost of his insurance by $720 a year. This is a foreign idea to us. Here in Manitoba, we went through a unit where we talked about insurance quite a bit. You just pay what MPI, Manitoba Public Insurance Auto Pack, tells you to pay, and you don't have many choices. You have the choice for how high you want your deductible. You want the choice for how much third-party liability you want to pay for. You also, I guess, have some choices as to how often you pay. Do you pay monthly, annually, whatever? But in terms of how much insurance you get, I guess you have one. There is the new car, right? If your car is worth more than $70,000, you want to add extra insurance, you can. But other than that, other places have, like, how much you're insured depends on how much you want to pay for it. And this is an example of that. If you live somewhere like that, you really got to think about what the probability is of the risks. Now, I don't know where this guy's driving, but I think in the real world here in our city, there's probably a higher % chance that you'll be in a collision. According to this, there's a 99.4% chance that Aaron will not have a collision in the next year. If he does, this extra insurance that he's paying $720 a year for gets him an extra $5,000 to fix his car. What is the probability that he will have a collision in the following year? Well, if there's a 99.4% chance that he doesn't, there's a 0.6% chance that he does. All right. right, what's the expected gain? Careful, for the company selling the insurance, not for Aaron. So a win for the company is that Aaron doesn't get in an accident. You're probably thinking, well, isn't that a win for Aaron too? Well, yes, because nobody wants to get in an accident. But that's definitely a loss for the insurance company because now they have to pay for the insurance that Aaron bought. So in this case, remember the formula? I'll write down the formula one more time since this is a new lesson. EV, here I'll write it smaller too so it's not so big. Maybe I'll use a smaller pen. Is that a smaller pen? There we go. EV, remember, is the probability of a win times how much you gain minus the probability of a loss times how much you spent, how much it cost. So now, if you're the insurance company, a win for you is not having to pay a claim. The 99.4% chance that Aaron doesn't have an accident. Does that make sense? Now, how much does the insurance company gain? Well, basically, they get to keep Aaron's $720, right? Because that's what he paid for the insurance. Now, it's a loss for the insurance company if he does have an accident. And as we just discussed, that's only a 0.6% chance. Careful, as a decimal, that's 0.006. Remember, you always move the decimal twice. Here's the other part to be careful of. I bet when a question like this is on the test, there'll be some people in the class who go, oh, there it is, they have to pay $5,000. Is that how much it really cost them? No, there's people shaking their heads. What do I have to do with that $5,000? Subtract the $720, because the insurance company doesn't give you back how much it cost you when they pay out your claim. That's their money to keep. So they don't lose $5,000, they lose $720 less than $5,000. And at this point, I like punching buttons. I don't need to know this number separately from that number. As far as I'm concerned, it's a scientific calculator. If it's working, it should just do this math in one fell swoop. 0.994. See, look at that, already I'm off. 0.994 times 720 minus 0.006 times, and then I'll actually do this in a bracket. Why not? 500 minus 720. Does everybody get why I needed the bracket? Because I need that subtract to happen before the multiply, and BEDMAS would say the opposite is true. So without that bracket, I'd get the wrong number. Enter, and look at that. That is not the number I got this morning. What happened? Because I didn't get enough zeros. I can fix that. Entry, and then go back and insert a 0. Oh, now I got to go minus 720. Close brackets. Equals. There we go. That's the number I got this morning. The expected value for the company is $690 of profit. Right? That's a positive number, right? This is positive, so it is good for the company. But now the next question, if you're Aaron, do you buy this insurance? Well, this can be argued both ways. Suppose Aaron is somebody who, look, if I don't have this insurance and my car gets $5,000 worth of damage and it doesn't run, I'll be without a car, I'll lose my job, get kicked out of my apartment, and die homeless on the streets. So for $720, I better spend it. But if it's somebody who's like, well, you know, we're a family and we have this as our second vehicle, and you know, if I'm without it for a while, maybe I'm paying for replacement insurance for when I do have a claim. I'd rather not spend an extra $720 on the very unlikely chance I have a collision. Look at what the math is telling me. I'm going to say that the answer here is no. Okay? The expected value for Aaron, the kid's name was Aaron, right? Yeah, Aaron, is negative $690. I should put a dollar sign on that. So from his perspective, this isn't a good deal. Of course, all insurance mathematically is not a good deal for you, but you have to weigh the risk and what is your ability to replace anything that you have lost if you don't have it insured. Okay, we got a question.
If we explain exactly why we said yes.
Yeah, you better, okay, the question is, well, what if you explained why you said yes on a question like this if it was on a test? Well, then you better be a good explanation. Because again, the numbers are very clear here. This is a bad deal for Aaron. This is taking $690 and throwing it out the window. Okay, but if you again explain, well, if the situation is that Aaron has to have a vehicle and would have no other means of replacing it or paying for the repairs without this extra insurance, then he's kind of stuck having to do it. Obviously, house insurance is going to work out negative for the customer, positive for the insurance company, but you have to have it. Okay? Some risks we have to take. So there we go. There's example 2. Rolling on to example 3. Now we get into the wide world of appliances. Dean is buying a clothes dryer that costs $825. Everybody's been around, maybe mom or dad or older brother or uncle or somebody when they're buying an appliance at a store. As soon as you say, I'd like to buy this one, the sales pitch comes, would you like to buy the extended warranty? So already there's people saying no. Some people are already like, they're always a scam. Not always, but let's do the math. The clothes dryer has a 1-year warranty from the manufacturer. They always come with that. If it breaks within 1 year, the manufacturer themselves take care of it. But the store sells you a 5-year warranty for $100. Now, I will show you after we're done the little lessons a website that's really good to go to. It's been around it's been a magazine since I think the 1950s, called Consumer Reports. They literally take data. How often does this brand of this appliance break down? They do cars, they do appliances, and they are ad-free. So one can hope that they are not being influenced by any of the major manufacturers or product makers. So you go to a place like that, you can actually find data on how likely the thing you're about to buy is going to break down. So here's something like that. The odds against needing repairs over the next 5 years are 17 to 3. Remember, this is odds against. So what's the probability that the clothes dryer will need repairs? Well, there's 17 times when it didn't need repairs. There's 3 times when it did. So that's 3 out of how many? 20. Right. Don't forget that there's 20 total things that can happen. 17 times you need repairs, 3 times you don't. Altogether, 20 situations. So 3 out of 20 is the right answer for that. So the probability that the dryer will not need repairs is the opposite, 17 out of 20. And now, let's say that the average cost to repair the dryer is $200. Obviously, some service calls would be cheaper, some would be more expensive. Let's think that's probably an average. So the company estimates it costs $200 to repair the dryer, and Dean buys the warranty. What's the expected value on that warranty? What's the gain? And again, this time we're not like the last lesson. We're not doing this from Dean's perspective. From the perspective of the store, is this good business for them? So what's a win for the store? A win for the store is that their product doesn't break down, and I get to keep Dean's money and don't have to go out and fix his dryer, right? So 17 out of 20 times the dryer should not break during the extended warranty, and I get to keep Dean's $100. But it's a loss for me 3 out of every 20 times when Dean's dryer does break down, and I have to go out and make a $200 repair. But remember, I still get to keep Dean's $100. So do you see why that's only a $100 gain? Or sorry, my bad. Only a $100 loss. Right? You don't get that money back. So I did the math on that. I ran the numbers. I punched buttons, and I got $70. And the fact that $70 is positive tells me what? This is good for the company. Okay? Therefore, positive $70 is good for the company. Now, Is it good for Dean? No. And now my scrolling isn't working. Come on, you. There we go. Should Dean buy the extended warranty? No. The expected value is positive for the store. So it's negative for Dean. He would be better off mathematically. Let's say that. Mathematically. Let's pick a 25-cent word here. Mathematically, my parents paid good money for my college education. I'm going to use all the big words I can. Mathematically, Dean is better off saving the $100 and taking, I wanted to say the sentence because I wanted this word to be in there. Risk. It is a risk. Maybe it breaks down literally 1 year and 1 day after the manufacturer's warranty runs out. And then he's going to be going, oh, why didn't I buy that $100 extended warranty? But maybe the dryer runs problem-free for 10 years. Then he'll be going, oh, why did I spend that $100 and ended up not needing it? Anybody, I guess maybe for people of the age of the people in front of me, buying appliances is not something you've ever done, but how many of you still buy physical copies of video games? Don't they offer you the protection, the game protection every time? Does anybody take it? No. Everybody's shaking their heads no. It is probably not in your best interest, right? Especially since, assuming nothing goes wrong with the disc. I mean, if there's something wrong with the disc, as soon as you open the box, they're going to take it back, right? You're going to return it. But what's the likelihood that the game gets damaged if you take care of it before you finish the game, right? Games are finishable now, right? You don't play them forever. Anyway, my kids always turned it down. Not once in all the games they bought did they ever buy the game protection. All right, let's change gears away from, actually, I'm going to come back to appliances after this next example. But here's one that's more social studies based. I'm going to get a history degree and I'm going to become a social scientist or a political scientist and I'll never have to do math again in my life. You're not so right about that. Okay, so the following bar graph indicates the number of hours a week that students in 3 senior 3 grade 11 classes watch television. Obviously, this is from an old book. You guys probably don't watch television the way previous generations would have. But let's play along. What's the probability? Could you imagine somebody? No, it's per week. It is per week. 20 hours a day. 20 hours a week. Well, okay, maybe this isn't such an old textbook then, because I think television watching is way down now that more people are on the internet. And okay, when I go home and turn on my smart TV and put on YouTube, am I watching TV?
Yes.
What does it mean to watch TV? Is that like network television? If I'm watching Netflix, am I watching TV? Not really. I'm streaming it through, instead of the computer, it's my smart TV. If you're looking at a screen, it's TV. I'm looking at a screen right now. Am I watching TV? I watch Netflix on here if I wanted to.
You're doing work on there right now.
How do you know I don't have Netflix on there right now? Oh, okay. I'm kidding. Okay.
You very well.
No, I have 2 different screens going. This is different than that. The technology I have at my fingertips here that frustrates me daily. Okay. All right, where do we start with this question? A student in these classes watches 12 to 16 hours a week. If I pick a kid at random, what's the probability that I'm getting one of those guys? They fit in the 12 to 16 hours a week category. Well, first of all, that's not one category. 12 hours a week, 16 hours a week. I'm going to call that 2 categories. I'm going to assume they mean inclusive. So they got 12 or 13 or 14 or 15 or 16 hours. How do I calculate this? Well, step 1, I need a total. How many people is this data? Sometimes these questions are nice and they tell you how many people it is. How much is it? It actually is 80. Good work. This is 4. This is 6. This is 8. This is 10, if you kind of, again, go across, right? This one's 16. This is 12. This is 10, this is 8. I'm going to double check this. And this is 4, and this is 2. Okay. 4 and 6 is 10, 18, 28, 38, 44, 54, 56, 66, 74, 78, 80. So, yep, total number of kids in these three classes is 80. So, which two categories do I want? I want, for this question, 12 to 16, I want the 8 and the 10. So that's going to be 8 plus 10 out of 80. So that's 18 out of 80. Did it say how it wanted the probability? Nope. So it's up to me. Can I leave it like that? Nope. Both of those numbers have a 2 in them. So that's 9 out of 40. You know what? In the world of statistics for the social sciences, they don't like fractions. Again, a lot of them are math phobes. Fractions, bad junior high math memories. So they might go to percents. So maybe 9 divided by 40 times 100, go to percent. And then if a politician's looking at this data, quick, get me on the news so I can complain about it so people will vote for me. 22.5% of our teenage population watches TV 12 to 16 hours a week. That's too much. They should be out doing wholesome things like catching frogs. I don't know. What are we supposed to do with our lives if we're not watching TV? What do they expect from us? I don't know. Exactly. That's right. I don't know. I don't know what they want from us. We're only so strong. TV's there and it's wonderful. Okay. All right. Moving along. Let's go with a bigger net, 16 to 28 hours a week. So that's going to be the 10 column and the 16 column and the 12 column and the 10 column. Add all that up and try to make your screen move. There we go. And that's all of, how much was it again? 80? That's 48 out of 80. Anybody see what number goes into those two? Higher than 2. Higher than 4.
8.
Higher than 8. They both have a 16. 48 is 16 times 3. 80 is 16 times 5. You do know that one of the great things about simplifying fractions is if you'd have said, oh, I noticed they both have an 8, and you'd have gone, that's 6 out of 10. Hopefully you notice, oh, wait a minute, there's still a 2 there, right? Remember, you don't stop simplifying until you know you're done. Anyway, if you want that as a percent, that's 60%. Now, this is interesting. What if I wanted the probability that if I grabbed a student at random from these three classes, I grabbed somebody who watches more than 4 hours of television a week? Well, there's only a few kids who don't watch more than 4. They watch 4 or less. They're in that block right here, right? That's the kids who their parents don't have a TV in the house, so they got to watch it at their friend's place once in a while. Those guys. We used to make fun of those guys. So anyway, what do we do with this? Okay, do you really want to add this number and this number and this number and this number? I mean, I already pretty much added all that. That's a better idea. The better idea would be, well, how about I just take the total minus those 4 guys that don't have a TV or whatever and divide that by 80. So that's going to be 76 out of 80. Anybody know what goes into those two numbers? Hint, how far apart are they? Yeah, they both have a 4 in them. So that's 19 out of 20. And again, if you had to leave it as a fraction, you'd stop there. If you prefer a percent, that's 95% of all students in those 3 classes watch TV more than 4 hours a week. Now, do you think the probabilities determined from these 3 classes hold true for all grade 11 students in Manitoba? Explain. And the answer is probably not. And I'll tell you why probably not. Using one school to represent the behaviors, and again, there I am picking words I can't spell, behaviors of the whole province is likely going to be invalid. The other word that comes to mind besides invalid when I make a conclusion based on my statistics that and my probability that probably isn't accurate is, of course, the word bias creeps in, right? What if this one school was a country school where they don't have cable television? I mean, I don't know that such places even exist anymore, but they used to. When I moved up to Lynn Lake, Manitoba in 1994, we had like 7 channels. There you go. That was quite a step down. I grew up as a kid with more than that. I grew up here in the city, so I was one of those kids that we had cable. I can't remember not having cable. My parents say that we got it when I was about 7 or 8 or something, but I don't remember. I always remember having at least the entire dial. Always had at least 12 channels, and then of course it expanded to, 50 something, and of course now there's hundreds. But having one small part of the population and you say, there's my statistics, I'm going to make a conclusion for the whole population, that's not usually a good plan. Okay, I'm going to stop my video there because I've reached the end of the examples, but I'm going to show you an example of exactly this, only a much more serious example of that. Okay, so I'm going to stop the video here.